Hello everyone, my students here, I've only got 4 students in specialist, but I have the best. 4 students, and one of them said, "Sir, can you give us a crash course on sketching on the Argand plane?" This is one of those things that if you get it, it's easy. It really is. See it, boom, 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 done, 4 marks, thanks for coming. If you don't, it's just in another language. It might as well be in German. Well, look, maths is kind of another language anyway. Here are 3 of the main types, okay? This one here, and I'll fill bits in here in a minute, is the circle style one. This one here, around the argument, looks like this. And then this one here, where we've got 2 bits and there'll be things in here, is the line one, okay? They are all simple when you know what you're looking for. Let's start, here we go. Right, so the circle one, I'm gonna put some numbers in here. Let's go Z minus, I'll go 2 plus 2i, for instance, right? And let's put a number here, let's say this is 4. Now what we need to recognize in this format, this here is telling us the center of the circle in this format, I'll come back to that. And this here is telling me the radius of the circle, okay? Now I say in this format because that exact same thing here could be written as Z minus 2 minus 2i. That and that is exactly the same. But if you just read out minus 2 minus 2i, you'll have the center in the wrong spot. Now, why is that so? This is the important thing. Make sure you understand why. This here is saying, what is the difference between some random Z, some point on the Argand plane, and this one? Okay? This is telling me work out the difference between some point, I'll get to that in a minute, and this one. Then once you've worked out the difference in real and imaginary, take the absolute value of that. Well, taking the absolute value of 2 points here and here, right? The difference here, right, might be, let's say it's 6 there, and let's say it's 2 there. Okay? So this bit inside here is working out 6 plus 2i. Taking the absolute value of it says, what is the direct distance between the two? That's Pythagoras. Therefore, what's this? 36 and 4, that'd be square root of 40. Yes, we can rearrange that. 4 comes out front, that'd be 2 root 10. Okay? So that is kind of the answer to this part. Then, the whole thing is saying, the points that I want to graph is when the absolute value of this equals 4. Well, the absolute value of this equaling 4 would say that when a particular point is 4 units away from this point, included. Now, if I have a particular point and I'm looking for all the points that are 4 units away, well, excuse my accuracy in drawing, here's a point 4 away, right? Here's a point 4 away. Here's a point 4 away. Here's a point 4 away. Here's a point. Here's a point. Here's a point. Can you kind of see what's happening? Here's a point. Here's a point. And again, with the accuracy of my drawing, doesn't that just give a circle? It's the set of points that are 4 units away from this point. Okay? Difference between 2 gives me effectively this. Well, actually, gives me that. Absolute value gives me this. And if the answer of that is 4, included. And when we do all of them, we end up with this. So on an Argand plane, I go to this point right here, because that's the one I'm trying to work from or work to. So 2 plus 2i. There we go. That point right there. That is the center of my circle. And I want the set of points that are 4 units away. So come down here, that point would be included, that point would be included, that point, and we would end up with a circle of radius 4 around that point. Now, because it's equals here, that's your answer, okay? If it was greater than, so the distance between these 2 points must be greater than 4, well then I would want the area outside that circle And the way it is at the moment, I would have to dash that circle line. If I do that, it would then include that circle line, wouldn't it? And then the exact opposite, if it was that, then we'd be talking about the area inside. Okay? Again, understand what this is telling you. Dead simple. 2 minutes, done. 1 minute. Oh, 1 minute. Not two. 1 minute and you're done here. Okay? So this is the first style. It's a circle. You see it like this. Circle of radius of 4. This is the center. Bingo, done. Pay attention to this. Easy. Moving on. Replay that if you need. I'm going to get rid of this, but you've got the video, so you can go backwards. Right. So this one. This is now talking about the argument of complex number z. The argument is the angle of the complex number. So if I had something like 0 is less than or equal to the argument of z less than or equal to pi over 4. Okay? All you need to do is read it like this first. There's your first equation. You want to read that one. And then you also want to read, damn it, wrong side, this one. They're the two equations you need to see in it. So reading the orange one, follow the color coding, reading the orange one, we want to find where is the argument of z, reading it this way, greater than or equal to 0. And then the other one is where is the argument of z less than or equal to pi on 4. Now, those are relatively simple when you realise the argument of z is just the angle. I don't care what the z is, the complex number. So on a Argand diagram, or this is saying that here's 0 degrees, radians, whatever, doesn't matter, and I want the things on that side of it, because that's going to be greater. Pi on 4 is going to be there, and I want things on that side of it, less than. So the answer really is just onwards forever. That's the section that fits both of these. And really, whatever we put in here doesn't make it any more difficult because it's just some wedge shape starting there. That's it. Sometimes these questions will, this will change the other way. They'll always be greater than or less than, not equals, because equals would just be a single line. Right? So they won't be equals in here, greater than or less than. And really, just read the two equations out. Bingo. Now, before we get over there, we can combine these two together by saying, determine when this intersects with or union of, whichever, this one. So we could bung the two together. Let's say, for instance, we did that one there, and let's say we had, I'll go z, the absolute value of z equals 3. Now that's actually the simplest version of this, because there's nothing there, so the center of the circle is at 0, 0. You could write this as z minus 0 plus 0i, if you want to see it that way. So this is saying that's the center of the circle, so it's here. Radius of 3, well, I'm just going to pick a radius and say 3's there. It's not really centered, but you get the idea. And then if I wanted, let's change this to less than. And if I want the intersection between those two, it would only be this section here that I want, right? If it was the union, then I would be taking all of this and this, right? Union, intersection, hopefully you're good with that. All right, rewind if you need. Hopefully that's good. That's not, this is kind of the easiest one, I think. Really, I think it's the easiest. Right, over here. Now see how each left and right hand side there is similar to this. That's different, but similar here. So use the same thinking. This is saying some random complex number z and another point, the distance between those must be, I'll put equals here, equal to that same random complex number point and some other point. let's put in some simple numbers. Let's go 1 plus 2i, and let's go, I don't know, 3 minus 2i, or 3 minus, yeah, that'll work, 2i. Okay, doesn't really matter, but let's graph it and see. Here we go. So this point here at 1, 2i. Oh yeah, that'll work. Fine. 2 and 1. That point there is that. This point is going to be 3 minus 2i. Now, again, don't hammer me on my scaling, but you get the idea. So that point there and that point there. Now, if I choose a random point Z, and you're not going to do this every time, but I just want to show you. If I choose a random point Z and say that Z is 2, 3, right? Now, if I work out this here, the difference between that, and find the absolute value, I'd be getting that distance there. If I did the same with that point and this point, I'd be getting that distance there, wouldn't I? Now, are those two lines the same length? No, they're miles difference. This is way shorter than that. So that complex number there is not one that I want in. That's not going to work. So let me choose a point that's a little more realistic. I'm going to choose the point, and I kind of did my numbers neatly here, the point right there. Now that point there, if I work out the distance between there and there, do I not get that one? And then if I work out, I'm just going to put a line here so we can see the break, between there and, oops, I rubbed it off, and there, excuse my drawing, it's not the best, I'm going to kind of cheat here, let me just cheat. Is that point there equidistant from that one and that one? Yes, it is. So that would mean that this particular point right here is a solution to this equation. In a similar way, this point just there, can you see how that would also be the equal distance between those other two? And in a similar way, this point would, and this point would, and this, and this, and this, and this, and this, and this, and this. Can you see how that's forming a line right through the middle? All the points along that line are equal distance from there. Have a look at this. If I pick a point, can you see how it basically makes a triangle every time? And they're similar, well, give or take my drawing, they're similar, they're not similar, they're congruent triangles. So therefore that distance and that distance are the same no matter which point on that line I choose. You might be asked from here, given this, give the equation in y equals mx plus c. Two ways you can go. You can substitute in x plus yi there and do it algebraically, square both sides, get rid of everything, move left and right and all of that. Or what you can do is you can say, well, if I know those 2 points right here, can't I find the point halfway between? And isn't that point on the line that I want? Tuck that aside. If I work out the gradient between those 2 points and then use the idea that m1 equals -1 over m2, if I know the gradient of that line, I can figure out the gradient of that one, bring in that point that I know is on the line, and I can solve. So there's 2 ways you can do it, algebraically here, or kind of visually, geometrically here. Whatever works for you, doesn't really matter. Whether you've got a calculator or not doesn't really assist either way. So, but this one is harder to see. Last point on this though, if this wasn't equal, right? If this was like that, how do I know which side of the line? Let me just tidy up my diagram. How do I know which side of the line is going to work? Well, there's 2 ways of doing that, okay? You can look at the diagram and do it kind of in a logic way. This is saying the distance between this point and the line, or sorry, the distance between that point and the line, which is every z value that works, must be shorter, less than this distance. So if I was to choose a point here, can you see how that distance, which is this one, is less than that distance? So therefore it would be this side of the line that I want. Okay? That is one way of looking at it logically. Pick a point that clearly is one side and visually see. The other way to do it is to take 0, 0, which is definitely on one side of the line, put it in there, so effectively that just cancels out. Then do your absolute value, see what you get here. That cancels out because it's 0, 0. Do your absolute value here and see whether it works. See if the answer that you get here matches that. If it does, then it's the side of the line that 0, 0 was on. If it doesn't, it was the other side. The only time this doesn't work is if the line goes through 0, 0. In that case, choose a point on one of the axes, so either your x or your y, your real or your imaginary is 0. Doesn't matter where you go, but choose something easy so you can throw it in. Either way is good. Now, you've got lots of time to go back and look back over here and dig through and whatever and all of that. I'm going to do another video in a minute. It's going to be this style, but there'll be a number out front here. That's kind of the tricky one. Anyway, hope you enjoyed this. Catch you later.